Good afternoon, students. Welcome to our new session. So, today we will be dealing with neutralization titration. So, in our previous chapter, we studied about this titration. This titration means it is used to determine the alkalimetry and acidimetry. So, we can call it as acid base titrations. So let's discuss an example. See, this is a acid and this is a base. When they react together, we'll get a salt and a water. See, this is NaCl salt H2. This is called neutralization reactions. So these reactions are applicable to strong acids, strong bases, weak acids, weak bases, and their salts also. See, acetic acid is a weak acid and this is a strong base. So when they are reacting together, we will getting sodium acetate plus water. So this is a salt and this is a water. So these type of reactions is called acid base reactions or neutralization reactions. So acids will sour tasting, bases will be bitter tasting and slippery. Next, acid base concept. So there are 5 concepts: Arrhenius concept, Bronsted-Lowry concept, Lewis concept, solvent system concept, and Lex-Flood concept. So let's move to first concept, that is Arrhenius concept. So Arrhenius concept was introduced in 1894 based on the acid base characters in the aqueous medium. So according to this theory, acid is a substance. When they dissolve in water, they liberate hydronium ions. And base is a substance. They liberate hydroxyl ions when they dissolve in water. So we can go through an example. See, this is an acid and this is water. They are reacting with water and they liberate hydrogen ions during these reactions and they result in hydronium ions. See, base, this is base and this is water. When they dissolve in water, they liberate OH minus, that is hydroxyl ions. So demerits. Demerits means we can use water only here. Other than water, no other solvent can be permitted. Then we cannot explain the basicity of the all types of the components like calcium oxide, ammonia, etc. Then Bronsted-Lowry concept. Bronsted-Lowry concept means acid is a species that donate proton and base means accepts proton. See, this is acid. So they'll donate proton and this is conjugate acid. And base means they'll accept proton. So any substance which function as an acid by Bronsted concept, we can call it as Bronsted acid. Base means Bronsted base. So acid means they'll donate proton, base means they will accept proton. Then merits. Merits means this concept is applicable to all ions that donate and accepts protons. And it is not limited to water alone. It is also applicable to gaseous phase. Demerits. Demerits means it could explain the character of a acid if there is a base. Likewise, it could explain the behavior of a base if there is an acid. This is the demerit. And it cannot explain the acidic nature of electron division components. Electron division components examples, that is aluminum trichloride is the best examples. Then Lewis concept. Lewis concept means acids are the substance that accepts electron pairs. Likewise, base means they donate the electron pairs. So H positive, it is an acid. So they will accepts electrons. Likewise, ammonia is a base. Base means they will donate electrons. See, this is the example. Then solvent system concept. Solvent system concept means acid is a substance that gives cation characteristics of a solvent. Likewise, base is a substance that gives anion characteristics of a solvent. So these are the some examples. So water. Wa- from water we are getting hydronium ion and hydroxyl ions. Likewise, from ammonia we are getting two type of ammonium ions. So in water, H3O positive means they are the acids. So they shows cation characteristics. OH minus means they are bases. So they gives us anion characteristics. Likewise, in liquid ammonia, that is we can see ammonium salt, they'll act as a acid. So they gives us cation characteristics. Likewise, sodamide, that is NH2 ion, they gives us basic characters. So they gives anion characters. And this concept is applicable to proton as well as non-proton systems. Then Lexfleck concept. So here acid is a substance that accepts oxide ion. Likewise, base is a substance that donate oxide ion. For example, calcium oxide and silicon trioxide. We will get calcium isosilicate. Likewise, lead oxide, we will get reacting with sulfur trioxide, we will get lead sulfate. So acid means they will accept protons, so it will become O4, and base means they will donate protons, so we will get O3. Then Pearson concept. Pearson concept means it is hard and soft bases and acids concept. Certain ligands. Ligands means what? It is a molecules that is attached to metal ions by the coordination bond. So these ligands will form stable complexes with heavier ions. Heavier ions means silver, mercury, platinum. These are the heavier ions examples. And these heavier ions will have full d orbitals. Likewise, the ligands will also form stable complexes with lighter ions. Examples barium, aluminium, tin, etc. But they do not have more d orbitals. Sometimes they will not have what no d orbitals. Sometimes few d orbitals will be there. So based on this, we are classified it into many sections. That is alkali metal ions, alkaline earth metal ions, or other light metal cations. So these ions having very few d orbitals. Sometimes they won't have any d orbitals. So, but they will having higher oxidation states. So we can classify it as hard acids, or we can say Lewis acids. So these acids are small in size. Also, the electronic charge are not easily polarizable. On the other hand, there is heavier metal ions. So heavier metal ion means they will have d shell orbitals, means completely filled d shell orbitals. So they can be classified as soft acids. So they are larger in size and they are easily polarizable also. So that means lighter ions means they are classified as hard acids and they are smaller in size. They are not easily polarizable. But heavier means heavier metal ions means they are classified as soft acids and they are larger in size. Also, they are easily polarizable. Next, ligands which choose more stable complexes. With hard acids, we can call it as hard bases. If it is soft acid means we can call it as soft bases. So hard bases means they are anions. They are not easily polarizable. And soft bases are also anions and they are easily polarizable. So this is Pearson concept. Sorry, actually soft bases are cations and they are easily polarizable. Anions are not easily polarizable. Then theory of acid base indicator. So there are two theories, Ostwald theory and Quinoid theory. We can call Ostwald theory also ionic theory. So here we are talking about indicator. So all indicator are organic acids and bases. So according to this theory, that is undissociated or unionized indicator. Undissociated means the molecule that is not getting separated. That is called undissociated. So let's see an example. See, this is unionized color. Means acid. Unionized indicator acid. So when they dissociate, we will get H positive plus indicator. So they will become ionized color. Likewise for base, they dissociated and we will get indicator and we will get one hydroxide. So they will become ionized color. So in acid solution, H positive concentration will be high, very high. So the ionization will decreases. So when ionization decreases, the concentration of indicator will be small. So color will be also less according to acidic medium. According to alkaline medium, the concentration of the H positive will decreases due to this OH minus. So the ionization will get increases. Hence the concentration of indicator will also get increases. So color will also increases. That is happening in the alkaline medium. See, by applying the law of mass action to this equation, so we are taking log. So while taking log, H positive will go this side and this will come this side. So likewise it will come. Then we are taking negative log. So in each thing we can see negative sign. Then while taking off this negative sign, this will come upward, this here. So pH is equal to pK, that is indicator plus log indicator divided by unionized indicator. It will come like this. Then KIN means it is the dissociation constant of an indicator. So actually the color of the indicator will depends upon the ionized and unionized form concentration, and they are directly proportional to pH also. If indicator is weak acid, ionization will be very low due to more H positive ions. If indicator is weak base means ionization will increases because H positive will converted into OH minus. It means H positive will react with this OH minus and they will result in water. So the ionization will be very large. Another example you can see the phenolphthalein. This is a weak acid indicator. So this is undissociated, colorless, and when they dissociate they are pink color. See, undissociated form or unionized form of phenolphthalein will be colorless. And ionized form means it will become pink color. So in the case of acidic medium, ionization of the phenolphthalein will be less. It will decreases. Ionization decreases in acidic medium. So equilibrium will shift to left hand side due to the high concentration of the H positive ions. So in acidic medium, phenolphthalein color will decreases. In alkaline medium, the equilibrium will shift to right hand side. This is due to the hydrogen ions is removed by OH minus in the form of water molecule. That's why equilibrium shifting to right hand side. Also the color will increases. So the concentration of phenolphthalein ion will get increases in solution, and they import pink color to solution when it is alkaline medium. When it is acidic medium, due to the concentration of H positive ions, the equilibrium will shift to left hand side. So the color will decreases. Next is quinoid theory. Quinoid theory means, according to this theory, they exist in tautomeric forms. Tautomeric form means it is a type of isomers, a change in positions and in structures, etc. So there are two forms, benzoid form and quinoid form, and these two forms having two different colors. The color change is mainly due to change in one form to another form. So one will be in acidic medium and another will be in alkaline medium. So during titration, they change alkaline to acidic medium or acidic to alkaline medium. This is mainly due to the change in pH. So for example, we can say phenolphthalein. So in acidic medium, they will be in benzoid form. It will be colorless. And when it is in quinoid form, they will become pink color and they exist in alkaline medium. That is quinoid theory. So that's for today. Thank you.